In this video, we'll explore how to model industrial steel buildings quickly using the Hall macro in ideCAD Structural. You'll learn how to define spans, bracing, and geometry, adjust story and foundation settings, and generate multiple connected halls in seconds. We'll also explode the macro to edit each element for detailed modeling. By the end, you'll know how to create complete industrial hall structures efficiently and accurately. The Hall macro is located in the Steel tab, right after the Crane command. I clicked it once to open the menu. In the window that appears, I hovered over the Settings command on the far right. But before diving into the settings, let me briefly explain what the Hall macro is used for. In industrial buildings, where there are repetitive frames with similar spans and geometry, the Hall macro allows you to quickly model the outer grid lines and generate the main steel frames. It essentially serves as a shortcut, combining many commands you've already seen in previous trainings, like steel columns, steel beams, slabs, purlins, and bracing, into one macro. After generating the outer frame, you can explode the macro and continue modeling intermediate stories and inner axes with more detail. On the left, you'll see two tabs, Form and Settings. Let's start by exploring the Form tab in detail. In the Hall table, there's currently one hall defined, and it contains 3 spans. Looking at the list, you'll notice that these spans have different lengths. You can assign different lengths to each one, or make them all equal by modifying the values in each field. To change the number of spans, simply adjust the count box below. For example, I changed it to 5. You'll also see that bracing has been placed in alternating spans. 1 span with bracing, 1 without. I selected the last span and enabled bracing there as well. Below the list, there are several commands like add left, add right, delete, and shift left, shift right, shift up, shift down. These let you add multiple halls and manage their layout. While one hall is selected, I clicked add left. Then I selected another and clicked add right. This way, I can quickly create multiple hall blocks. When a new hall is added, it copies the geometry of the selected one, but of course, you can adjust it afterward. If you want to apply the same geometry to all of them, hold Ctrl and click each hall name. They will change color to indicate they're selected, and now you can modify all of them simultaneously. Now, let's look at the geometry of this form. The L1 parameter represents the total span of the hall. I set it to 20 meters. L2 refers to the ridge position. I adjusted it to 10 meters, centered. We also have H1, H3, and HD. H1 is the steel column height. Since I'm creating a 3-story building, I set it to 900 centimeters. W1 and W2 represent the wall heights on the left and right, often used for brick walls and models. I set both to 0 because I don't want any walls here. S1 and S2 control roof slopes. HD is an extra height parameter used when you want an elevation difference between the left and right sides. There are also 2 commands, adopt to left and adopt to right. When working with multiple halls, you can use these to ensure roof slopes align between neighboring halls. Moving to the next section, you can choose the hall shape as triangular, rectangular, or arc. For beam types, you can choose between portal beam and truss. I reduced the number of wind columns to 2. Between the steel columns and the foundation, reinforced concrete columns are automatically modeled at a default height of 30 centimeters. I'm keeping the default for now, but you can modify it later if needed. Now let's go to the Settings tab. First, we'll check the story settings. As I mentioned earlier, This works as a shortcut to the general story settings we've shown in previous trainings. I defined a total of 3 stories here. Below, you'll see shortcut commands for the left, right, and roof parts of the hall. These commands are linked to familiar tools for modeling steel columns, beams, ties, and bracing so that I won't explain each one again. Instead, they allow you to make quick bulk adjustments. You'll also see reinforced concrete (RC) shortcuts. Because footings are modeled automatically as single footings. If you want to switch to a different foundation type, you can explode the macro after modeling, delete all footings, and define a raft or continuous footing instead. I clicked OK and selected a starting point in plan view. The lower toolbar provides command prompts as needed. I confirmed the operation, and the hall was modeled. Let's quickly review the result. As you can see, it created multiple halls aligned along the same axis. You can double-click on any hall to open its properties again. I returned to the Form tab and selected the middle hall. I clicked Adapt to Right, and it adjusted the geometry to match the neighboring hall. Then, I selected the leftmost hall and changed its shape to rectangular. The model updated instantly. I increased the number of spans to 7 and added bracing. The macro updated the model automatically. As I mentioned at the beginning, the hall macro lets you quickly model the outer frame. To start modeling the internal parts, you first need to explode the macro. To do that, I selected the macro, right-clicked, and chose the Explode command. Now, all elements, like purlins, beams, columns, and bracing, are available individually, and you can edit them one by one. You can adjust the purlins, edit their connections, or split them at intersections. These edits can be made in both 3D and plan views. From here, you can continue modeling the inner axes and floor systems using the standard tools we've already covered, like steel column, beam, slab, and purlin commands. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.